I'll start here. 5.2 is in the back of the class if you need to pick it up. So what we're kind of in now is we're at the point of this class where we're focusing on graphing functions a lot now. So the next thing we go to after quadratic functions is we go to polynomial functions. And what I'm going to do is teach you a lot of definitions today and kind of get through that today. So what a polynomial is it's a function that contains sums and differences of whole number powers of x. Okay, does anybody out there in my audience know what a whole number is? What is it? You sort of know what one is, but you can't describe it? Okay, it starts with 0, and then it's numbers you count with your fingers on. 1, 2, 3, 4, 5. So what I want you to write in this blank is this. Put a set brace and then just go 0, 1, 2, 3, ... Okay, you probably have heard of a whole number before, but it starts with 0. That's kind of the important thing on there. Okay, so what we mean by a polynomial function then is I want you to notice each of these examples. Right here, the exponents are whole numbers. You have a 3, you have a second power, and x is x to the first. So every exponent must be a whole number. It has to be, okay? Even the 8/3. When you see that 8/3, technically that's 8/3 x to the 0. Because x to the 0 is 1. Anything to the 0 power is 1, so that's okay. Okay, the next problem, look at this. Okay, you have a whole number power. 5 is a whole number. And you always have sums and differences. So you separate the terms with plus and minus signs. So that's what polynomials look like. Here's a polynomial right here. Again, that x has a first power. That's perfectly acceptable. The last one is a polynomial. You want to write a note on here. This is the same thing as 5x to the 0. It means exactly the same thing because x to the 0 is 1. Okay? So that's kind of what it is. So let me show you how to make a polynomial. Okay? We're just going to make something up. Okay? It's a lot of times easier to just define a polynomial this way. So let's just put a couple, like 2 or 3 x's on here. Now, all you got to do is just pick some whole number powers at random. I'll just say that's 12, that's 3, that's 5. Okay? Then all you got to do is you either put a plus or minus however you want to, and boom, you've got a polynomial function, okay? And the individual parts of that are called terms. So this has 3 terms. 1, 2, 3 terms. The terms are the things that are separated with plus and minus signs then, okay? All right, let's go to another one. Here's how you make another one. Okay, I'll do this. This one will have a few other extra things. Just put maybe like 3 or 4 x's. Let's put 4 x's in there. Randomly, just start picking whole numbers. You could even put a 1 on one of them. 7, 8. You can put any number you want to in front of these too. So if you want to put a number in front, you can. If you want to put a fraction in front, even if you want to put like pi in front. But the thing is, they're always separated with plus and minus signs. So that's what polynomials are. Think of it as sums and differences of powers of x where the powers are whole numbers, okay? Only other thing you could have maybe is just one term. So it is okay to just have something like x to the 11th or something like that. You got to at least have one term. Okay, all right, do we understand what I mean by a polynomial function, yes or no? Okay, sums and differences of whole number powers of x. Okay, a lot of times students kind of know what a polynomial is, but they can't really explain what one is. Okay, definitions, terminology stuff. Okay, so let's kind of go over these together, and let's kind of look at these. Like this first one, my question to you is it a polynomial function, yes or no? Do all of the x's have whole number powers? Yes, okay. Are they separated with addition and subtraction signs? Yes, so that is a polynomial. That's what it looks like. Good. What do you think about the next one? You're shaking your head no. How come? Good. Okay. It's got a negative exponent. So write a little note to yourself that we can't have negative exponents. So you can't have negative exponents. Okay. That's good. Okay. How about the next one? Square root of 2x to the 5th minus x to the 4th. What do you think? At least shake your head. There we go. I'm seeing a lot of people shake their head this way. That's right, it is a polynomial. And the thing is, you've got whole number powers of x. It's okay to have a square root of 2. You can have any number you want to in front of x. Okay, that's not an issue. How about the next one, x to the 0? Yeah, how come that's okay? Because 0 is a whole number, right? Okay, so that's okay. All right. How about the next one? I see some people are going this way, few people are going this way. So put them together, okay? No, this is no. The reason it's no is because you have a fraction, okay? What you have in this problem is you have a polynomial on top and a polynomial on bottom. You can't do that, okay? It's just got to be sums and differences. So that's no. You know, it's no. This is what we call a rational function. So, you know, no fractions, okay, like that. Nothing like that. You can have a fraction as a number in front of a term, but you can't have that like that, okay? So we're just going to kind of start simple with terminology, okay? Go ahead and do the next 5 problems. I'm not going to walk around on this. I just want you to do them and kind of compare your answers and just yes or no. If it's a no, write a note to yourself why it's not a polynomial. All you're looking for again is whole number sums, I'm saying that wrong. Whole number powers of x, sums and differences, okay, like that. Okay, so I'll just give you a minute to do that and we'll check and see if we're on the right track. I forgot to have you all sign the attendance today too. I just noticed that. So go ahead and pass that around. And then there's 2 problems on the next page. So let's just take like 30 more seconds to do this and kind of see what we get. All right, so I think a couple of things in there are a little different than what I showed you. So let's kind of see what we get. Okay, well, let's go ahead and look at them. Okay, yeah. Oh, you're just wanting to participate and give me answers?
No, I was just going to ask.
Okay.
I was going to ask a question about.
Okay, please go ahead.
What happens when there's y to the 4th?
You can only have one variable. Let's say I kind of threw that one at you. Okay, I kind of threw that one at you. If it says g of x, then all of the variables need to be x. Okay. All right. So anyway, what did you come up with on number 1? Yes or no? There we go. Okay, good. That's a yes. Okay, number 2 is no. I don't know how many people spotted that, but it's because you can't have 2 different variables. So, you know, you might write a note to yourself, only one variable is allowed. Okay, I just sort of threw that one at you. Okay, so if it says g of x, then that means their variables are x. Okay, how about number 3? What did we conclude there? I think that one's pretty simple. No, how come? Okay, no negative exponents. Good. Okay. All right, so that is not a polynomial. All right, very good. How about number 4? It is a yes. It is a yes. Okay. Okay, so I don't know how many people spotted this, but this is the same as, you need to understand, this function is the same as f of x equals 6x to the 0. Okay, what is anything to the 0 power? Do you all know that? It's 1, right? Okay, so it's really 6 times 1, and 0 is a whole number, so that's a yes. Okay, all right, I know some of you fell for that one. Okay, that's all right. How about the next one? What do you think? No. Okay, remember, all you can have is powers of x that are whole numbers, and we do have powers of x, and then all you can have is numbers in front. You can't do a square root of a whole thing or anything like that. So that's no. Okay, all right, that is not following the definition. So really no square root over an entire polynomial, okay? To keep it simple on here, if you go back and kind of look at problem 1, they all got to look like problem 1, okay? It's just you have at least an x with a whole number power. Even if it's like 6, that's 6x to the 0. And then you can have numbers in front of x and then plus and minus. That's it, okay? Keep it simple. Sums and differences of whole number powers of x is what it is. Okay. All right, so the next thing we're going to look at is, again, more terminology. A lot of just vocabulary is what I want to kind of get through today. So the degree of a polynomial is the highest power of the function. Okay, we'll look at that with some examples here. So you find whatever the highest exponent of x is, and that gives us what we call the degree of the polynomial. Okay, the leading coefficient, the word coefficient means a number in front of something. So it's the number in front of the x to the highest power, okay? And then basically terms are the parts separated with addition and subtraction signs. And then this is pretty logical. If your trinomial has you have 3 terms, that's a trinomial. If it's 2 terms, it's a binomial. 1 term is monomial. That's just using prefixes, tri for 3, bi for 2, mono for 1, okay? So what I'm going to do down here, and some of your web work, homework on this section will be just boom, boom. About half of it is just fill in the blank stuff, just definition stuff, okay? All right, so let's start with this A here. Okay, I said the degree is the highest power in the problem. What's the highest power? Okay, so that's a 3rd degree polynomial. The degree is 3. Okay, the leading coefficient is always the number in front of the highest power. I'll just abbreviate that LC, so that leading coefficient is going to be 2. We're learning this because when we learn how to graph polynomials, the degree and leading coefficient tell you most of what you need to know anyway. Okay, how many terms does this have? So that would be 1, 2, 3, 4 terms. Those are just the things separated with plus and minus signs, okay? So it has too many things to be a trinomial, binomial, or monomial. That's just other. Sometimes you'll hear it called a quadrinomial. Typically, once you get past 3, we don't give it a special name anymore. Okay, that's just kind of the idea there. Okay. All right, what do you think on part B? What do you think the degree is? 2, good. What is the leading coefficient? 1. Because it's the number in front of the highest power. So you understand that there's a 1 in front of x squared. Okay, how many terms in this problem? There are 3. So what do we call it? A trinomial, good. Okay, all right, just trying to get the vocabulary down. There are 3 terms, all right? Okay, how about the next one? What do you think the degree is? It's not 1. Who said 0? I think I heard 2 people say 0. Okay, 0 is correct. Here's why. Remember I said a few minutes ago, you can think of this as 8x to the 0. A number is really 8x to the 0. The leading coefficient then would be 8. Okay, so that's what you get there. Don't let that trick you. A number is a 0 degree polynomial. It has 1 term. The only term is 8. So that's called a monomial, like that. Okay? All right, so that's kind of the special case. Any questions so far? Okay, don't let that constant term throw you. Okay, now the next one, you have to do a little calculation in your head on the next 2. It's not a hard calculation, though. So the idea is you could multiply this out. We're not going to multiply it out because it's a total waste of our time. I mean, you could FOIL the first together, then you could multiply by the last, and you would get kind of the polynomial multiplied out. All you really got to do on the degree is simply look at the highest powers and multiply them. So what you want to write on your paper is just do x times 2x. What is x times 2x anyway? 2x to the third. Good. X times x is x to the third. That's what the meaning of a third power is. Okay, so that's it. Okay. Now, what do you think the degree is now? 3, good. Okay, what do you think the leading coefficient is? 2, good. So you don't have to multiply the whole thing out. You just got to look at the right pieces of this. Okay, so that's 2. Okay, now how many terms on this? I shouldn't have even given you that problem. Just scratch it out. We don't need to know that, trust me. Okay, it's got more. I can assure you that it has more than 3 though, but we don't need to figure out how many terms it has. That's pointless to even talk about that really. And the same thing on the next problem. You can scratch that out too. Okay, all right. So on this next problem, when we do the degree, here's really what you need to do. You need to look at the 3x and the second power, the -4 and its power, and you also need to look at the 2. They're all important for finding the leading coefficient. So on your notes, you want to write down 2 times parentheses 3x to the second times parentheses -4 to the third. Okay, you have to think about this. See, the idea is if you multiplied that out, which would be a nightmare to multiply that out, you just wouldn't even go there. It turns out the highest power is going to come from this calculation. So what we're going to have is you're going to have 2. Now do this carefully. 3 to the second is 9, and then you'll have x to the second. Okay, if you do 3x times 3x, that's going to be 9x to the second. You know, write it out twice if you need to. Then if you do -4 to the third, that would be -64. If you do -4 times -4 times -4, you're going to end up getting, oh, hold on, I did something totally wrong on that. I don't know why I did that. You need to make one little change here. I have no idea why I did that. You need to highlight the x and the 3. It's the x that matters, not the 4. So write that instead as x to the third. My apologies. I should know better than that. Okay. All right. So just look at the x's and the powers. And if there's a number in front, that's pretty important too for the coefficients. So what you're going to have now is 2 times 9x squared times x to the third. Okay. Because you're just doing x times x times x is x to the third. Okay. What do you get when you do 2 times 9x squared times x to the third? What do you think? 2 times 9 is 18. X squared times x to the third is? Yeah, x to the fifth. Okay, you're saying that kind of quietly. Okay, a lot of times students don't know their rules from algebra. What you do is you add the exponents. Okay, and you got to understand why you do that. X to the second is x times x, right? X to the third is x times x times x. I wrote it down 5 times. Okay, so it's really x times x times x times x times x. Okay, that's what that is. So what you get is 18x to the fifth. Okay, now what do you think the degree is now based on that calculation? That's 5, good. What do you think the leading coefficient is? 18, there you go, good. Okay. Okay, that can be a little tricky for students. There's a little bit of background issues that might show up in there. Okay, so again, when you see both of these cases, it's the x's that matter. So that's why on this I did x times 2x. That's why on this problem I did 3x to the second, x to the third. You got to pay attention to those exponents when you do that then. Okay, is there any question about that? Okay, I can tell a lot of you were shaky on x to the second times x to the third is x to the fifth. Does everybody understand why? Understand, that's just x, x. This is x, x, x. That's 5 of them, right? Okay, understand the y part of that. Okay, next one will be very similar to this. So what we're going to do on this next one is, again, highlight the anything that's got an x, and if it's got a number in front of it, then that's really important. So the calculation we're going to do is 4x to the third to the second times x to the second to the fifth, okay? So a little background issue that's going to pop up now. If you have x to the second to the fifth, here's what this really means. Now, you don't need to write this down, but I want you all to understand that you multiply the exponents in this case, and you need to understand why. The y part is simple. If you have a fifth power, you know that a fifth power means to write down something 5 times, right? That's what that means. You write down x squared 5 times. Now look at this. That's xx, 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 xx. Wouldn't I write that out 10 times in total if I wanted to? Yeah, so it's a shortcut. These rules are shortcuts. So what we're going to have is you're going to do 4 to the second. You got to do 4 to the second, which is 16. And then 3 times 2 to get x to the 6th. And then the next one would be x to the 10th like that. Okay? So what happens when I take 16x to the 6th times x to the 10th? What do I get? 16. Thank you. Very good. Okay, add the exponents. Okay, now we've done everything we need. Yeah. You can, but the reason I want you to do it this way is to help you figure out the leading coefficient. But yeah, you're 100% correct. If you take the 2 plus 5 would be 7. You have to pay attention to both the 3 and the 2. You have to pay attention to all the exponents in the problem. Okay, that's important. Okay, so what do you think the degree is now? 16. What's the leading coefficient? 16 also. Okay, that's it. Okay, don't worry about number of terms. We're not the slightest bit concerned about that. Don't worry about it. Okay, I shouldn't have put that on there. Okay, go ahead and go to the next page and just kind of see what you can do on these. I'll give you maybe about 3 minutes or so to do this. The first 1, 2, and 3 are pretty automatic, hopefully. Then when you get into 4, 5, and 6, you want to see if you can do that kind of calculation that I just showed you how to do. Okay. And again, the purpose of this is you have to know this information to learn how to graph. All right, so number 1, the degree is 1. That's the highest power. Leading coefficient's 1/3. This has 2 terms. That's a binomial. Okay, the first 3 are pretty straightforward. Number 2, the degree is 5. Leading coefficient is -1. It's just that highest power. It's got 3 terms. That's a trinomial. Okay. What was the degree of number 3? Did we catch this now? What is it? 0. Thank you. Remember, this is the same as -6.8 x to the 0. Leading coefficient then would be the -6.8. This has 1 term, so that's a monomial. Those are the very straightforward cases like there. All right. Do you have any problem with those, or is everybody okay with those? Okay. All right. It gets a little more challenging here. Now, what you're doing on this is you're looking at the powers of x that exist in the problem. And because it's a multiplication problem, you're multiplying. So you have x times x to the 2nd, which is x to the 3rd. That tells you what you need to know. So the degree is 3. The leading coefficient is 1. Okay, that's what you get on that. That's all the calculation you got to do. Okay, I saw some issues on 5. So you do need to pay attention to that -3 because that will help give you the leading coefficient. Then again, what you're going to do is you're going to look at x to the 4th and you're going to look at x to the 10th. You look at x and you look at the powers of x. So you're going to do -3 times x to the 4th times x to the 10th, which is -3x to the 14th. So what you should have got on this is a degree of 14 and a leading coefficient of -3. I saw several people not pay attention to the -3. You have to. Okay, that's the idea. Okay, and then the next one, you're going to look at 3x to the 2nd and 4 and 2x and 2. You do have to look at that 3 and 2 because those are going to have an impact on your leading coefficient. So you work out 3x squared to the 4th times 2x to the 2nd. Okay, you want to make sure you did this okay. 3 to the 4th is 81. You multiply the exponents. 2 times 4 is 8. And then again, you're doing 2 to the 2nd is 4 times x to the 2nd. So what you would have, I think, what is that? 300 and what? 324. Thank you. So it's 324 x to the 10th. So what's the degree? 10. Leading coefficient. 324. Okay, how'd we do? Okay, see, this is easy stuff. It's all terminology, okay? All right, that'll wrap us up today. Thank you for participating. All right, I'll see you on Thursday then. And there's no work due this week, which is kind of rare, but we're done with the test. But don't just take a vacation. You want to start 5.1, you want to start 5.2, and that written assignment you picked up today, okay? So get going on it.